This is lesson unit 5, lesson 7. We are going to be writing exponential functions into logarithmic functions and vice versa, and then we want to evaluate a logarithmic expression. So first of all, how are exponential and logarithmic functions related? They are inverses of each other. Okay, so like addition and subtraction are inverses of each other. So if you have an equation like x plus 8 is equal to negative 17, you would use subtraction to solve this because subtraction undoes addition. So you would subtract 8, and then you would be able to figure out what x is equal to. Same thing for multiplication and division. So if you have x divided by 7 is equal to 32, you would multiply both sides by 7 because multiplication and division are inverses of each other. They undo each other. So x would be equal to 225, I think. No, 4. Okay, same thing with squares and square roots. So if I have x squared is equal to 121, if I take the square root on both sides, because squaring and square root are inverses of one another, they undo each other, so x would be equal to 11. And so then this is kind of the same way that exponents and logs work with each other. So we're going to talk about how to So the first thing we want to do is, given y equals 2 to the power of x, we want to rewrite it as an inverse function. So if we know that logs are the inverse of exponents, this would be log base 2 of y is equal to x. Okay, so when you convert it into a logarithm, what do you notice happens to the exponent? So just looking at this one, if we have 2 to the power of 3 is equal to 8, the way that we can rewrite this is log base 2 of 8 is equal to 3. So what happens to the exponent? Well, the exponent starts out right here, but ends up over here. Okay? So the exponent actually is the answer to this log problem. So all logs are is a way to solve for exponents when you don't know what the exponent is. Okay, so the relationship between the exponential and the logarithmic form. So the bases are the same. Okay, this is the base of my exponent. This is the base of my logarithm. Notice that those two things are the same. The exponent becomes the answer over here, and the answer for this one becomes the number right after the log on this one. So we have all the same numbers, they're just in different positions. So the big thing to remember is that the base of your exponent is the same as the base of the log. Okay, so the answer to a logarithm is the exponent of the exponential. Okay, so here's the exponent. It is the answer to the log. So if I wanted to say, if I just gave you this part and said evaluate this, what you're looking for is the exponent on 2 that would give you an answer of 8. So 2 to what power is equal to 8? Well, that answer is 3. Okay, so if I said log base 3 of 9 is equal to what you're looking for is the exponent of 3 that will give you an answer of 9. So 3 to the power of what is equal to 9? Well, that would be 2 because 3 squared is equal to 9. So here's how you can think about converting in between these two, and these go both directions. Okay, so this way, and this way. Okay, so if you have a to the power of y is equal to x, then this is how it would convert into a log. And if you have log base a of x equals y, this is how it would convert into an exponential. So what we're going to do first is we're just going to rewrite each of these so that they are in exponential form. So remember that this base is going to stay the base. Okay, so this base of the log is going to stay the base of the exponent. And then these two are just going to switch places. So this becomes the exponent and this one becomes the answer. And you should be able to check it. If you take 8 to the power of 0, you should get this number over here, which is true because anything to the power of 0 is always equal to 1. So for this one up here, same thing. The base of our log, so if we have log base 2 of 1/16 is equal to -4. The base on our log is going to stay the base of our exponent. The answer here is going to become the exponent of this one. And then the fraction or the number over here is going to become our answer. And so again, you can think about this. If you were to take 2 to the power of -4, you should get 1/16. So let's think about this really quick before we move on. We know that 2 to the 4th is the same thing as 2 times 2 times 2 times 2, which is 16. So 2 to the 4th is equal to 16. But we don't have 2 to the 4th, we have 2 to the -4th. So remember, a negative exponent just takes this and does the reciprocal. So instead of 16, it would be 1/16. So 2 to the -4th is in fact 1/16, so this should make sense. Okay, so now what we're going to do is write each equation in exponential form, but you notice that we have a little bit of a different we don't have log anymore, we have ln, which is the natural log. So anytime that you see ln, it is equivalent to log base e. Okay, so these two things are the same thing. Okay, the reason that we want you to know ln is because on your calculator you're not going to see a log base e button, you're going to see an ln button. So anytime that you see ln, you can replace it with log base e. And most of the time you won't see the log base e, you will only see ln. So you need to know that ln is the same thing as log base e. The other thing that you might see is just log without any base down here. So usually we're used to seeing like log base 2 or log base 5. If there's no number down here, then that is the same thing as log base 10. Okay, and I know we touched on this a little bit, but you again will not see a log base 10 button on your calculator. You will only see a log button. Okay, so that's why we want you to understand that just the word log means log base 10, and just the abbreviation ln is the same thing as log base e. So for the first one here, since I have ln of 1 equals 0, ln I can replace as log base e of 1 is equal to 0. So remember, this is going to stay our base. This becomes our exponent. This becomes our answer. So anything to the power of 1 is always equal to 1. So this is the correct way to write this. Again, we have an ln, so we can write that as log base e of 9 is equal to x. So again, this is going to become our base. And then these two just switch places. So this is e to the power of x is equal to 9. So now we're going to turn this around and we're going to write each equation in logarithmic form. So we're just going the reverse direction from the last problems that we were doing. So again, I have 10. That's going to become the base on my log. So this will be log base 10. And then these two just switch places. So this is going to be 1,000. And then this is going to be what it's equal to. So remember, anytime that you see log base 10, you can also rewrite this as log of 1,000 is equal to 3 because this no number down here implies that it's a 10. And so all this is saying is 10 to the power of 3 is equal to 1,000. 10 to the power of 3 is equal to 1,000. Same thing over here. The 9 is going to stay the base of our log. So log base 9. And then these two are just going to switch places. So this is of 3 is equal to 1/2. Okay, so what power of 9 gives us 3? Well, it would have to be a 1/2. It has to be something less than 1 because 3 is less than 9. Again, write each equation in logarithmic form. So e, anytime that you see an e, you can rewrite it like this at first. So log base e of 1, remember these two, these two trade places of 1 is equal to 0. Now, the preferred way to write this would be ln of 1 is equal to 0. So this whole thing right here gets replaced by ln, okay? The 1 and the 0 stay. Same thing with this one over here. We have log base e of x is equal to 6. So this whole thing right here turns into ln. So ln of x is equal to 6. Okay, so we talked about this a couple of days ago. If we want to evaluate this, what might help us? Well, take that 64. So if we have log base 2 of 64, we can take the 64 and rewrite it. So log base 2, we want this 64 to be written as a power with a base of 2. So this would be 2 to the 6th power. Now, if we rewrite this as an exponential function, it would be 2 to the power of what is going to be equal to 2 to the power of 6. Well, if the bases are the same, then in order for these two powers to be equal to each other, their exponents have to be the same. So that means that this would be 6. So if we were going to evaluate this, 2 to the what power is equal to 64, I can see that it would be 6. Same thing with this one. Okay, we want log base 3. We want that 81 to be written as a power in base 3. So 3 to the what power is equal to 81. That would be 3 to the 4th. And so now we just want to rewrite this. 3 to the power of what is equal to 3 to the power of 4? Well, we know that the answer would be 4. Okay. Next one. So now what we're going to do is we're going to take this logarithmic expression and we're going to turn it into an exponential expression. So we have 6, okay, because remember, the base of the log becomes the base of your exponent. 6 to the power of something is equal to 6 to the power of 8. Well, we need to figure out what this is, so that would be 8. Okay, all this is asking you is 6 to the power of what is equal to 6 to the power of 8. Well, the bases are already the same. Now we just need the exponents to be the same, so that would be an 8. All right, so I've got the last two up here. And we're going to take this one and we're going to rewrite it in logarithmic form. Okay, so some people in class freaked out today because they were like, what? A log is in the exponent. Yep, it sure is. So all we're going to do is remember that the base here becomes the base of our logarithm. Okay, so we are going to have log base 3, and then this becomes the part on the other side, and this is what we're looking for right here. So log base 3 of something is equal to log base 3 of 4x plus 1. So what would have to go here in order for these two to be equal to each other? Well, I have log base 3 here and log base 3 here. So the answer should just be this part right here. So this would be 4x plus 1. So I want to go back and I just want to remind us what was the answer for this one. So when we evaluated this one, our answer was 4. When we evaluated this one, our answer was 8. And when we evaluated this one, our answer was 4x plus 1. So what's happening here? Well, remember, exponents and logs are inverses of each other. So if I have this right here, and I'm taking an exponent of 3 to the 4th to the log base 3, these two are inverses of each other. They're going to cancel each other out. They're going to undo each other. And so what we're left with is just our exponent. Same thing here. I have an exponent with a base of 6, and I have a log with base of 6. And so these two inverses will undo each other. And so all we're left with is that exponent, which is our answer. Same thing for this one, just in a different way. We have 3, which is our exponent, or our base, to the power of log base 3. So again, we have a base and a log base 3. These two are going to undo each other. They're going to cancel each other out, and all we're left with is our answer. So what can we conclude about exponential or logarithmic functions? If the base of the log is the same as the base of the exponent, they're going to cancel each other out. Okay, so this is where we get this property from, the inverse property of logarithmic and exponent functions. So if you have log base b of b to the power of x, these two, because this is a log with base b and this is an exponent with base b, these are going to cancel each other out. And so all you're left with is x. Same thing here. You have an exponent with base b and you have a log with base b. These two are going to cancel each other out. They're inverses. They undo each other. And so all you're left with is this part right here. So for example, and this doesn't just work with logs, this also works with ln, because remember, ln is just log base e. So for example, if we had if we wanted to evaluate this, okay, I know that this is a log base e. This is an exponent with base e. So the log and the exponent are going to undo each other. And so this would just be equal to 7. Okay, same thing with this. If I have log of 10 to the negative 2, right? Remember, even though there's no number down here, we assume that it's base 10. And so this log base 10 and this exponent base 10 are going to undo each other. They're going to cancel each other out. And so the answer would be negative 2. Same thing over here. If I have 7 to the power of log base 7 of 12, I know that I have an exponent with base 7 and I have a log with base 7. These two things are going to cancel each other out, and our answer is just going to be 12. Same thing here if I have e to the power of ln of 16. I know that this is log base e. I know that this is an exponent with base e. These two are inverses of each other. They're going to undo each other, and so our answer would just be 16. So these are the last 4 examples that we have right here. We're just going to evaluate each. So take the time, pause it really quick, see if you can get these 4 on your own, and then unpause it and see how you did. So for the first one, remember that ln is the same thing as log base e. So if I have a log with base e and an exponent with base e, those two are inverses. They are going to undo each other. So the answer here would just be 3. On this one, I have an exponent with base 8 and I have a log with base 8. Those two are inverses of each other. They're going to cancel each other out. Our answer is just going to be 4. Same thing over here. I have a log with base 7. I have an exponent with base 7. These two are going to cancel each other out. Our answer is going to be 5. Last one, remember ln is the same thing as log base e. So I have an exponent with base e. I have a log of base e. These two are inverses. They're going to undo each other, and our answer is just going to be 6.